Alright, so in this video, we are going to start with the program solution for the selection sort algorithm. We are going to follow the selection sort algorithm from before line by line. Alright, but to make the process a little bit faster, I have implemented a few basic lines of basic methods which are required for our program. So for example, we have the void input method, which would help us take input in an array. We have the void display method, which would help us display the contents of the array. And this is the method that we have to create. This is the method whose body we need to fill up, right? So I've written the algorithm and I've commented out the paths. So let's begin, right? The first thing that we need to do is we need to store the length of the array in a variable size. So in size equals arr.length. All right. Now we must run a loop which would run from 0 through size minus 2. So for int I equals 0, I less than equals size minus 2, I plus plus. Now within this loop, we must first find the index of the smallest element of the array in the range I to size minus 1. Now is the perfect time to recollect the improved version of our third prerequisite. How to find the index of the smallest element of the array, right? So now we are not finding the smallest element from 0 and size minus 1. We're now finding the smallest element in the range I through size minus 1, in the sub-array I through size minus 1. So the index of the first element in this sub-array is I. And recollect that we were storing the index of the first. We were assuming that the first element was the smallest, and hence we were storing its index in smallest underscore index variable, right? But here in our sub-array, the first element's index is I. Therefore, we're going to write it here, int smallest underscore index equals I. All right. Now we need to search for the smallest element from I plus 1 to size minus 1, right? Because we have already assumed that the smallest element is present at I, so we need to search if there exists any other smaller number than the assumed one. So we're going to need a loop now. But because we have already used up or exhausted the variable I in the outer loop, we can't reuse it here anymore. So we need a new variable now. So I would start from I plus 1, j would start from I plus 1, j would run till size minus 1, and j plus plus. Now, we need to check whether our current element, now the indexes have changed, mind you, it's no longer I, it's j. So the current element for finding the smallest element would be arrj, right? So we need to check if the current element is less than the assumed smallest element. If it is, then j is the new smallest element's index, and that is what we are going to store in smallest index variable. Alright, so the first part's done. After that, we need to swap arri with arr smallest index. Recollect from prerequisite 1 how we used to swap the content of two variables. So in this scenario, the variable a is basically arri and variable b is arr smallest index, right? So in temp equal to a, so here a is arri, let me write that. It will have good mapping. A is arri and b is arr smallest underscore index. All right. So in temp equals arri equals arr smallest index, and arr smallest index equals temp. All right. So that's it. That's our selection sort done. Now let's move on to the main method. So in the main method, we have created an object of the scanner class to take input, and we've created an object of this class which has a name of selection sort to call these methods. Now first we're taking the size of the array as input, then we are initializing the array, allocating memory to the array, and then we are taking input in the array through the help of the input method that we had written earlier. Now Because we are sorting the array, therefore the positions of the elements would vary before and after sorting. To show that we have actually sorted the array, it is best to display the contents of the array before and after sorting. Therefore, we are displaying the contents of the array before sorting, and then we will want to make a call to the selection sort function that would sort our array, and then we are displaying the contents of the array after sorting. So let's see this program in action now. Compile, class compile, no syntax errors. Bless me. Alright, so let's use the same array from before. The size is 7, the first element is 38, next is 41, it's 18, 50, 68, 22, 84. So the contents of the array before sorting is this, and the contents of the array after sorting is this. Alright? Okay. Now, here's a challenge for you. What change? It will be just a single change in one line, right? So, let's say three changes. Let's say three changes, all right, or four changes. So, what are the changes that we need to do in our selection sort function so as to sort the array in descending order instead of ascending order? What do you think we must do? Pause this video for a moment and think. All right. To I'm going to write a new selection sort function now. All right. So let's call this selection sort ascending. Right. Let's copy this. Paste. And let's call this selection sort descending. All right. So the changes that we must do is we must find now the largest element of the array in the index id size -1 and store it in a variable largest underscore index. Remember, it's not two separate programs, it's just a single method, just we are changing a few variable names and a sign. This is going to be largest index, and the sign will flip from less than to greater than, and this is going to be largest index. And we're going to swap arri with arr largest index. That's it. Done. All right. So we have seen the contents of the array after sorting. So selection sort ascend. We've seen with selection sort ascending. Let's call selection sort descending. All right. Let's compile this. Let's run it on the same array as before. So the size of the array is 7, and the element 1, that's 38, 41, 18, 50, not 520, 50, 68, 22, 24, 68, 22, and 34. Contents of the array before sorting is this, contents of the array after sorting is this. See, it's sorted in descending order. So just 3 changes, and we've got our descending sort algorithm, right? So it's better that I show you the algorithm as well, because it's easier to remember the algorithm than the code, right? So let me do something. Let me duplicate this slide, and let's write ascending beside this, ascending order. Okay, and this is for, haven't I copied it? Yes, I copied it. Oh, I didn't. Let's copy it again. Please give me some time. I'm really sorry for this. I know the video has gone on for too long, but just give me a couple of minutes. Okay, let's copy this, duplicate this. All right, we have it now. So descending order. So the algorithm for sorting in descending order would be to change smallest to largest. And that's it. So I'm going to make the changes in this color. Instead of smallest, this is going to be largest. Let's store it in a variable named largest index, and we're going to swap ARRI with largest index, and that's it. For descending order, the job is done. All right. So this was the last video in a series of selection sort videos. So if you still have any doubts, I would suggest you to go through these videos a couple of times. Give it a few times. This is a relatively new algorithm for you. This must be a relatively new algorithm for you. So give it some time, and it will come to you. Practice it a little more. This will come to you. All right. So okay then. Bye for now.